Hello everyone. So in the last session we studied about Pelton wheel turbine, which was basically a impulse turbine with high head and tangential flow. So in this session we'll see what is Francis turbine, which is basically a reaction turbine with medium head and mixed flow. So mixed flow means the water enters radially and exits axially. In case of Pelton wheel turbine, the water used to hit the turbine blades tangentially, right? Here, the water hits the turbine blades radially and exits axially. So that is why it is mixed flow turbine, and it is medium head. That means the water falls on the turbine blades from medium heights. In case of Pelton wheel, in the previous case, it was high head. That means the water used to fall on the turbine blades from higher heights, but here it is medium head. That means medium height, and it's a reaction turbine. The concept of reaction that we'll explain in this turbine. So coming to the construction of this, see, as you can see here, it has got shaft, runner, guide blade, spiral casing, draft tube, and as well tail race. Correct. So this is the front view of the Francis turbine, and here you can see the top view. So here also you can see the same parts: shaft, guide wheel, runner, guide blade, spiral casing, etc. So for the explanation sake, I think the top view will be more comfortable to understand the concept when compared to this front view. So for time being, you just ignore this front view and concentrate only on the top view. See what happens here is, coming to the working of this, see, flow of water is shown like this. So initially the water enters the turbine like this, that is radially, and the water hits the turbine blades. See, if you can observe here, there is a guide blade and moving blade. So the guide blade is basically fixed blade, and the moving blade is usually the runner blade. The runner blade is moving. Okay. So initially the water hits the guide blade, that means fixed blade. What happens there? When the flowing water hits the fixed blade, it gets deflected. So see here, the water is flowing. That means it has got some kinetic energy, right? When this moving water hits the fixed blade, the water gets deflected. So once the deflected water hits the moving blade radially, understood this? So the flowing water first hits the fixed blade, and this water will gets deflected, and that deflected water will in turn hit this moving blade, that is these inside blades, radially, and by that time the turbine starts rotating. Okay, so when the turbine rotates, the kinetic energy of water is converted into mechanical energy. And when this turbine rotates, even the rotor rotates. That is like, if this is the shaft, this will be the turbine and this will be the rotor. So to the same shaft, the turbine and rotor is attached. When the turbine rotates, even the rotor rotates. So both will be rotated simultaneously. And what happens when the rotor rotates? Some electricity produces. So here the mechanical energy is converted to electrical energy. So that is how a Francis turbine works. And if you can observe here, there is a draft tube. Once the water hits the blades, it will be exited through this draft tube and it will reach the tail race. So from tail race, the used water can be further utilized for some agricultural purposes. So hope you understood this Francis turbine, which is basically reaction turbine with medium head and mixed flow. Okay. So next there is one more turbine for your syllabus, which is KAPLAN turbine. Okay, which is basically reaction turbine as in case of Francis, and it is low head. It is not even high head or medium head, it is low head, and it's an axial flow turbine. That means water enters axially as well exits axially. Coming to the construction of this, again there are guide vanes, spiral casing, vertical shaft, okay, boss or hub, tail race, and the flow of water and the directions are shown like this. Okay, so here the water enters axially, and hits the blades of the Kaplan turbine. As I explained in the Francis turbine, it first hits the fixed blade and the water gets deflected, and then it hits moving blades axially only, and the water will be exited to the draft tube. So then from tail race it can be utilized for some agricultural purposes, right? So when the moving water hits the turbine, what happens? The kinetic energy of water is converted to mechanical energy of the turbine. So to the same shaft, the turbine as well, the rotor will be attached, as I explained. And once the water hits the turbine rotates. When the turbine rotates, since it is attached to the same shaft, even the rotor rotates. So what happens? Some electricity produces. So what happened here? The mechanical energy of the turbine is converted to electrical energy of the rotor. So electricity produced, and that is how the Kaplan turbine works. Since it's a low head, it has got some specially designed blades, because it has to provide some sufficient force to rotate the turbine. No, so these are the specially designed blades, so that even from the low head the turbine can rotate efficiently. Yeah? So the Kaplan turbine is basically a reaction turbine with low head and axial flow. Yes, hope you understood this. Thank you.